In this video, we are going to learn about how we can organize our code using modules and packages. We will learn about modules and how we can import module using import statements. We will also learn about packages which will allow us to organize the code at a higher level. Let's learn about all of these concepts in code. Python provides multiple techniques to organize our code. One, using modules, and second, using packages. In simple terms, you can think of modules as simple Python code files and packages as Python code folders. Let's understand about modules first. Modules are files containing Python statements or Python code. Modules are created to arrange our code into manageable files. This makes it really easy to manage our code base and maintain it. If we had a single monolithic file with large code base, that will be very difficult to manage. Instead, if we break down our functionality of a system and write all of them in a separate file, then it can be very easy to maintain. This also allows for reusability of the code. Let's see a very simple example of a module. Here in this case, I have opened up the project folder in my Visual Studio Code editor. Here you can see a very simple Python file, mymodule.py. In this very simple file, I have two functions which performs the addition of two numbers and multiplication of two numbers. If I want to make use of these functions from this specific file, then I can use it in my code. For importing those two functions, I can simply write import and then the module name. Module names are usually the same as the file name but without .py extension. So here I write import my module, and now I have got access to both the functions from this module. If I want to use, let's say, add function from the module, then I can simply write mymodule.add and I can pass two arguments into it. If I execute this, you can see that it returns the addition of those two numbers. If I want to use the multiplication function, then I can write mymodule.mul and pass two arguments into it. It will perform the multiplication of those two numbers. In this case, we have to write the module name first and then the function name. But writing this module name may be difficult every time, especially when the module name is very large. So in that case, we can also rename the module to something else. We can write it like this: import my module as my, and now if I want to call any of this function, I can simply write my.add and it will actually access this function from this module. Here we cannot access the function directly. For example, if I try to do add 2, 3, then it's going to throw a name error. Add is not defined. Every time we want to call a function, we have to prefix it with the module name. If we don't want to do that, then we can make an explicit import. For that, the syntax looks like this: from my module, import specific item. In this case, I'm importing only the add function. Now I can access this add function directly like this. If I want to import multiple items, I could perform that in multiple ways. So there is something called import everything that we can write like this: from module name, import star. This star symbol will make sure that we are importing everything from the module. This is very dangerous and should not be used because it can cause Name conflicts. This happens when we already have an add function into our scope from, let's say, some other library, and we try to import the same name add from our own module. This will override the functionality of the earlier add function, and this can cause some complicated bugs which will be very difficult to debug. So always try to avoid this import star statements. Instead, you can import specific items like this. Let's say I want to import both the functions, then I can write it like this. This way, we are at least sure that we have imported add and multiplication function from our own module. Now if I check multiplication of 2 and 3, then it works directly. If we want to avoid the name conflict for these functions, then we can also rename them. Here, I'm going to import the same functions, but I'm going to rename them to something else using as keyword. So in this statement, I am writing import add as my add and import mul as my mul. Now, if I want to access that add function, I can access that using this name. So I can write my add 2, 3, and it will get the sum of those two numbers. This way, we can rename a function when we import it into our scope. Python also provides some built-in modules. One of them is the math module, which is very important when we want to perform some mathematical operations on numbers. Let's import that math module and see some of the functionalities. Once we have imported the math module, I can check all the functions using dir function, dir math, and I will get list of all the functions defined in this module. You can see that it has many of the trigonometric functions. It also has some functions to work with numbers. It has this constant e, as well as it also has a constant for pi. Let's look at them in code. Math.py, and I get the value of pi. Math.e, and I get the value of this constant. If I want to check help on any of the functions, then I can get that using help function. For example, let's try to get some help on this ceil function. So I can write help math.ceil. It will print a very simple documentation string from this ceil function. It returns the ceiling of a number as an integer. Let's play with that. Math.ceil of 3.2, and I get back 4. So this function returns the closest integer which is higher than the provided number. Similarly, if I check math.floor of 3.2, it gives me 3. But if I check math.floor of 3.8, it still gives me 3. So it returns a floor value of a number. Similarly, it has a function for finding the square root of a number. We will also learn about some other modules as we go further in this video series. Let's now learn about packages. Packages are like folders which contain different modules. This also means that it is a folder with Python code files. This provides a higher level of code organization. Let me show you a simple example of a package. In my VS Code, I have this project folder open, and here I have this package. In order to create a package, we have to have this _init_.py file. It's totally blank, but we still need this file in order to create this package. We can write some initialization code in this file, but in this case it's totally blank. And here I also have this sample.py module which contains one function greet. Inside this package we can also have another package. For example, in this case I have this another nested package, package1, which also has this init file and the same myModule file. This time I have added this subtract function into this module just to verify that I am importing these functions from this module and not from earlier module. Our folder structure looks like this. I have this outer folder, my package, and inside that I have this init file. So this means this my package becomes a package. Inside this I also have this package1 folder, and this also contains init file. So this is also another package which is nested inside this my package folder. I also have this sample.py file which is inside this my package. So that's the module which is inside this my package folder. I will keep this diagram on the side so that you can check the imports. Let's go back to code. To import my greet function from the sample module, I can write something like this: import my package dot sample as sample. So inside my package I have a sample module and I'm renaming this thing to sample. Once I have imported this, I can use the function greet from the sample module like this. If I want to import anything from the folder, then I can use this dot notation. Similarly, if I want to import anything from the inner package, then I can use the same dot notation. Let's say I want to import from my module. You can see that my module is inside the package1, which is the inner package in this case. So I can write something like this: import my package dot package1 dot my module as module1. So I'm creating an alias for this import as module1, and I can access the add function from this module like this. We can also import specific function from the inner module as we saw earlier. Let's say I want to import only the subtract function, then I can write like this. Now I can use this function and it correctly executes that function. So this way we can break down our larger code into modules and packages. These are reusable piece of code. So if we want to use the same functionality in, let's say, some other application, then we can simply import this package or module and we can have that functionality available in second application. In this video, we looked at modules and the import keyword to import specific code from a module. We also saw a variety of import statements to import different functionalities. And finally, we looked at packages which help us in code organization at a higher level.